Let's try to do another online assessment. Let's get started. A school is trying to take an annual photo of all the students. The students are asked to stand in a single file line in non-decreasing order by height. Let this ordering be represented by the integer array expected or expected. I is the expected height of 5 students in line. You are given an integer array height representing the current order that the students are standing in. Each height I is the height of the ith student in line with 0 indexed. Return a number of indexes where height I is not equal to expected I. So the first one, the input is 114213 and output is 3. And the explanation of that is 114213 and the expected is 111234. So indexes 2, 4, 5 doesn't match. Wait, what? Oh, okay. So expected is sorted, I think. Can I just sort them? I think I can just sort them. And I just compare for each one. Create a sorted. I think create a sorted height, iterate I from 0 to n minus 1 if like sorted height I is not equals to height I, then answer plus plus. I guess that's the whole idea. Okay. This will pass. Just wait, but that's too simple, right? I still have one more question. So it's probably not as simple as that. And then I'll try to let me try to sort them first. Let me try to put everything into sorted height first. Well, actually, I think there is a thing in Java we can just call clone, and then I just already sorted height, and then I iterate that. Sorted I is not equals to height I plus plus. I think that's the whole idea. So if I run through the example, it is just 1 and 1 is the same. I guess it's exactly what it does in the explanation, so it will return 3. Yeah, I think that actually works. And run the code. Wait, what? Okay. It's just missing a semicolon. 3. Yeah, I'm not gonna bother with the other test case. It shouldn't be that hard. Okay. Solved it. Yeah, so this will be O n log n. I'm sure that will be a faster solution if I use something like a bucket sort. But anyway, it got accepted, so I don't bother. Anyway, next question. Your friend is typing his name into a keyboard. Sometime when typing a character C, the key might get long pressed. And the character will be typed one more time. Return true if you examine it. The typed characters of the keyboard. return true if it is possible that it was your friend name with some characters, possibly none, being long pressed. Okay, it just means that some characters have repeated. No? Wait, that's too easy. Or am I very smart? Definitely not. I guess the way to do it is just so for example, name is Alex, and then typed is AALEGX. So you can choose to move this, so you match, and the other A, well, you can either match it again. For example, its name could be AAAA, and typed could be AAA again. And then, yeah, you want to match them. You want to match this and this. And the last one, you don't want to match them. You want to purposefully match all of them. If there is anything more, then you just say that it has been typed more, I think. Or we can use DP, but I don't think we need to do DP. So I've been thinking, well, there's like 2 ways to solve it, but I don't think it is necessary to do DP. No. Let's assume that I'm going from here, A. There's like 4A here. And then what I need to do, I don't know actually. Let me think. So it is 4A, and then should I hold on? Typed. So I iterate from, it's like a 2 pointer, I think. 1 pointer is from the name, and the other pointer is from typed. So if they match, then I match them. Let's say here. If they match, then I match them. Yeah, if they match, then I match them. If they don't match, let's say if they match, 2 pointer, I think. I is for name, J is for typed. If name I equals to typed J, and then J, and then just I plus plus J plus plus, and else, if they are not equal, it means that I cannot do I plus plus because we cannot use this type to match it. Then I just use J plus plus. No, it makes the most sense to just J plus plus until, well, if you reach the end of typed, okay, well, that's exactly it. Well, you cannot just J plus plus. Okay, now I think because you cannot just randomly add one to type. I know. So this wouldn't work. I++. This J++ wouldn't work because let's say name equals to ABB and then typed equals to AAA, and then the first character, well, AAA, let's say ACBB. So this wouldn't work because at C you would just J++, but you're not allowed to do that because it's not a long press from the previous character. Okay, so I guess I would just do the DFS then. Okay, that actually makes sense, I think. Okay, so it's like DFS IJ return true if we can use typed I all the way to, let's say, m minus 1. Okay, sorry, this one is J. We can use to match name I minus 1. I think so. This will be the recursive code that we're doing, and then we can either do, I think if they don't match, then I just return forced. If they match, then I can just return an arbitrary +1 if the next one is also my character. Yeah, I think so. But that would be too slow, I think. To 1,000? Yeah, to 1,000 I think that's fine because it's like 10 to the power of, 10 to the power of 3, is it? 1,000 is a 10 to the power of 3. Probably not. Probably not. It's not fine. If it is 100, that will be fine. Then it will be too slow. Sorry, I'm not smart. I'm dumb. I cannot solve it, I think. So let me keep trying. DFS RG should return true if we can use type J dot n minus 1 to match the name I dot n minus 1. Okay, I guess there's the way to do it. Is we need to know what's the next character that is not this character. I think so. Yeah. Last character. So it's like next different. But even that, you need to do a for loop to see if like either one of them is true. Okay. Well, it's still 2-pointer then. I guess you don't do DFS because it makes sense first to just to do I++ and J++ if we meet something that both of them are correct, both of them matched, like A and A is matched, then it doesn't make sense for we to do anything. But the thing is, if they both match, should I increment both both the pointers or just increment one of the pointer. Well, I guess I should increment. Actually, I'm not entirely sure about that as well. Let me think. First name, you should increment. So if they are the same, let's say the first word and the last word, which is the name and the characters are the same, I just increment both. If they are not, I guess I just need to know where is the name ending at. I need to know the next difference of this A. So it's ending in here. So that means that we'll try to do for it's the next difference. It's like a consecutive. Starting from there. Okay. Yeah, I think so. We need to do the next diff of I. Next diff. Next diff of I. This basically means that where's the next character that will be different than the current one, which probably will be some sort of index of the closest index of such that let's say name indexed is not equal to name I, for example. I think that's the gist of that. So next diff I is just the index such that the name index is not equal to the name I. Such that name index is not equal to name I. Okay, so I need to have this next diff thing. So then I can do the two pointer again. If name I is equals to typed J, then we'll need to know the next diff. Then I equals to next diff of I, and then J equals to next diff of J, and then return first if next diff J minus J is smaller than next diff I minus I. You need to do a pre-check first. I also just return first. I think so. But the way you do the next diff is just doing, well, there's the fast way to do it. If you because this only consists of lowercase letter. So I just need to know the well, next diff. I need this next diff. Next get next diff as, and then this is the length. Well, this is the result. And eventually just return this result. For each character, for each index, I just want to know what is the next index that is gonna match that. Or it could be never. If s.char at j is not equals to s.char at I, then rest I will be j and break, because this is going to be the next point to jump to, so to speak. Okay, I think that actually works. And then I need the name next div and the type next div. Name next div will be get next div, and name, and then type next div will be get next div, and then type. And then what we're going to do here is to just do this, I think, for 0 less than, I need to iterate. Yeah, I need to have a two pointer. Okay, I need to do a two pointer. Actually, I don't need to do a for loop. And then m will be typed of length. Just return true if I can actually reach the end. So while like I is less than n and j is less than m, so actually it should return I equals n, because it means that we can reach, okay, maybe not, and j equals to m. I think so. So if name.char at I, so the first character here is actually equal to the typed.char at j. So if that's the case, then what we want to do here is to do this check. If next diff j minus j is less than next diff I minus I. Just return first if that's the case. Because, for example, name equals to a and then typed equals to AA. So the length of this repeated is actually less than the name, the repeat length in here. So it means that we cannot match everything on name, and that will mean the next different character. So I equals to next diff I, j equals to next diff j. Name next diff. Or just name next diff. This is type next diff. Okay, this is name next diff. Okay, I'm so good. Anyway, it shouldn't bother me that much. Think so. So that's the thing, if none of this actually match, that would mean the next difference is gonna be the end. So I just erased fill rest as length by default. I think that actually works. So if it's AA, so there's the next difference of A is just L. The next difference of this A is this L. So they match again. The next difference of this L is E. The next difference of this L is E, this one. And this Z, E, the next difference of this E is X. The next difference of this E is the X. So you should return true there. And similarly, the next difference of this S is going to be A. It's going to be here. The next difference of this E is going to be here. The next difference of there is D. And then because the length of that, with the type length of that is actually smaller than the name diff of that. So we just return first there. I think that actually makes sense. Wait, what? Okay. I equals 0, j equals 0 again. Return true, SADD, and then SSAADD. You should return first. Let's see if that works. Okay, seems like it works. And the time complexity of this is just O n squared, I think, and like n squared plus m squared actually. O n squared plus m squared. The space should be O n plus m. I think so. Actually, I can optimize this a little bit, but I'm, too lazy to do that. And this one is O n log n. Time O n log n space O n. Yeah, that's pretty much all. By the way, I'm still thinking about the question yesterday. Why is pairing 10. Well, I guess it's totally unrelated to this video. And I hope you enjoyed something. Anyway, I should show the result first. Totally forgot. This is easy actually. I don't know. I thought it was like harder than easy. It should be medium. Anyway, I guess that's pretty much all. I guess it will be medium if the time constraint is a little bit higher, but anyway, hope you learned something. And that's pretty much all. Bye.